Section 4, Equipment Lubrication Management. Part 1, Objectives and Tasks of Lubrication Management. Lubrication refers to a series of technical and organizational methods to control friction, reduce and eliminate wear on equipment. This is known as equipment lubrication. Lubrication plays a crucial role in extending equipment life. The purpose of lubrication is to provide proper lubrication to equipment, reducing and eliminating wear, extending the service life of equipment, reducing frictional resistance, and lowering energy consumption. What are the specific tasks involved? The main tasks include: first, establish lubrication management policies and work guidelines. Define the responsibilities of lubrication personnel. Second, collect lubrication technologies and management information. Establish lubrication technical archives. Issue lubrication cards to guide operators and dedicated lubrication personnel in performing lubrication tasks. Third, confirm the lubrication materials and consumption quotas for each piece of equipment and timely prepare lubrication material plans. Perform timely oil changes and implement routine inspections. Conduct regular checks. Follow condition-based maintenance and oil change procedures. Shift from time-based maintenance to condition-based maintenance. Lubrication management should include the following core content. First, determine specific methods and objectives for equipment management based on national and corporate management policies. Second, set up a feasible lubrication management organization and establish policies. Third, prepare lubrication charts and distribute them to each piece of equipment. Lubrication charts must be concise, accurate, and standardized. Implement the 5 fixes for mechanical equipment lubrication: fix quality, quantity, interval, point, and person. Part 2, Lubrication Management System. Chemical enterprises establish lubrication management systems. Typically, these include equipment lubrication responsibilities, oil storage and management, oil dispensing, lubrication oil management and usage, lubricant substitutes, standards for lubricating greases, and recycling of waste oils. The main systems include 3-stage filtration and the 5 fixes. First, let's discuss 3-stage filtration. 3-stage filtration means that lubrication oil must undergo several container transfers and movements before being applied to lubrication points. Generally, the oil needs to go through several container exchanges and position adjustments before being used at the lubrication points. Each time the container is exchanged, it should be filtered to prevent secondary contamination by impurities. First, storage filtration. Oil is pumped into the storage tank and must undergo strict filtration. Second, distribution filtration. Oil must be filtered when dispensed into lubrication containers. Third, oil addition management. Oil must be filtered when added to the equipment's storage parts. 5-point system. Implement lubrication according to the oil quality standards through the 5-point system. Fixed point: quality, quantity, time, personnel. First point, define the lubrication points and positions for each piece of equipment. Ensure cleanliness and integrity, and implement point-specific oiling. Second, quality, define the type, grade, and quality requirements of lubricants for each lubrication point. Only oil that has passed inspection should be used, and the appropriate type of lubricant must be added. Lubricating devices and oiling equipment must be kept clean. Third, quantity, determine the quantity of oil or grease required for each lubrication point. Ensure proper lubrication while implementing daily consumption quotas and routine oil changes. Fourth, periodicity, determine the intervals for oil or grease changes at each lubrication point, as well as the oil quality inspection cycle. Lubricating oil should be added according to the defined schedule. For oils with large quantities, samples should be taken and tested periodically. Based on the oil quality, determine cleaning, oil changes, cycle filtration, and sampling intervals. Fifth, personnel, assign responsibility for oiling tasks to operators, maintenance workers, and lubrication personnel for each equipment lubrication point. Clearly define the division of labor for daily oiling, cleaning, and oil changes. Each person has their role, and mutual supervision is encouraged. Designate the person responsible for sample collection and testing. Part 3, Technical Documentation for Lubrication. Chemical enterprises often use various lubrication management charts for equipment lubrication. Equipment lubrication management charts refer to the charts or technical documents created by the Equipment Management Department to standardize, systematize, and regulate lubrication tasks. These charts also serve as guidance for planning, record-keeping, and statistics. They mainly include equipment lubrication cards, oil change cards, cleaning and oil change schedules, implementation plans, oil volume statistics, and application forms, among others. Part 4. Lubricants. There are many types of lubricants. How do we choose the right one? The selection should generally consider the following 3 factors. First, the actual operating conditions of the mechanical equipment, that is, working conditions, including workload, speed, temperature, media, etc. Second, specifications or recommendations provided by the equipment manufacturer. Third, specifications or recommendations provided by the lubricant manufacturer. Additionally, performance parameters must be understood. The first parameter to understand is the operational performance, which involves simulating the working conditions of the mechanical equipment and the conditions for using lubricating oil in a laboratory setting. Evaluate the lubricant's performance, including oxidation stability, wear resistance, acid value, and mechanical impurities, among others. The main physicochemical properties include viscosity, which is categorized into kinematic viscosity, dynamic viscosity, and relative viscosity. Pour point, the highest temperature at which the sample oil no longer moves when cooled under specified test conditions. Flow point, the lowest temperature at which the sample oil can still flow when cooled under specified test conditions. Common sliding bearings and rolling bearings have both grease and lubricating oil options available. The selection should be made according to the manufacturer's specifications. The commonly used engine oil is also known as system loss oil or mechanical oil. The performance is shown in the chart. The commonly referred to 32 #engine oil refers to its kinematic viscosity value of 32 mm per second. The lower the viscosity, the lower the operating temperature. Conversely, the higher the viscosity, the more viscous the oil. It is suitable for use at high temperatures, while also considering other factors. Part 5. Lubrication methods and lubrication devices. Lubrication methods refer to the techniques used to lubricate equipment components. Lubrication methods can be classified into oil lubrication, solid lubrication, and gas lubrication, depending on the lubricating materials used. Common material lubrication point supply methods are shown in the table. The main methods of lubricating with oil include the following. First, manual oil filling. This method involves manually operating an oil gun or oil can to add oil, with no adjustment for the oil quantity. Second, drip lubrication. This method involves placing lubricating oil in an oil cup, allowing it to drip onto the moving friction parts through its own weight. Third, splash lubrication, also known as oil bath lubrication. This method uses high-speed rotating components or oil discs and oil slingers attached to shafts to splash oil from the oil pool onto the friction surfaces. The oil is splashed or carried to the friction surfaces in contact with each other. Fourth, oil ring, oil chain, and oil wheel lubrication. The oil ring, oil chain, or oil wheel is mounted on the spindle and rotates freely. This method carries oil from the oil pool to the lubrication points, forming free lubrication. Fifth, wick, oil pad lubrication. This method involves immersing oil ropes or oil pads in oil and using the siphon effect to supply oil. Sixth, mechanical forced oil lubrication. This method uses a small plunger pump mounted on the oil reservoir. Driven by mechanical or electric motors, the pump pushes oil from the oil pool to the lubrication points. Seventh, oil mist lubrication. Eighth, centralized lubrication. This will be studied independently after class. Part 2. Solid lubrication methods. Solid lubrication commonly uses lubricating grease, graphite lubricants, and other solid lubricants. Depending on the situation, methods such as integral lubrication, coverage lubrication, composite material lubrication, and powder lubrication may be used. This will not be discussed further here. The commonly referred to greases, such as butter and lithium-based grease, are types of lubricating grease. The grade of grease refers to its viscosity. Grade 000 is the thinnest, while grades 1, 2, and 3 become progressively thicker, with grade 6 being the thickest. How much lubricant should be applied to the equipment? The oiling standards are as follows. First, oil lubrication. If there are oil level markings, they should be followed. If there are no markings, the following guidelines should be observed. First, circulating lubrication. The oil level in the oil tank should be maintained above 2/3 during normal operation. Second, oil ring lubrication. Third, immersion lubrication as shown in the diagram. Forced lubrication should be determined according to the relevant technical requirements and actual conditions. Second, grease lubrication. When the speed exceeds 3000 rpm, the grease amount should be 1/3 of the bearing housing volume. When the speed is less than 3000 rpm, the grease amount should be half of the bearing housing volume. Lubricating oil degradation should be dealt with. This is mainly done through sedimentation filtration and similar methods, or by using sedimentation clay contact treatment for filtration. Remove mechanical impurities and harmful components from the oil. Alternatively, professional companies can handle the treatment. The treatment methods used include physicochemical and chemical methods. Students interested in this can refer to the relevant literature. This concludes the course. Thank you for watching.